Hi and good day and welcome to Virtual Classroom for DSC1630. We're busy with chapter 7 and section 1, and it's all got to do with bonds. My name is Adil Immelman and I'm the lecturer for the Virtual Classroom for DSC1630. Now, what is bonds and what do we really want to determine with bonds? What is it all about? Now, if you and I want money, we normally go to the bank and we ask if we can maybe get a loan for a certain amount of money. But what does the big institution or government institution do if they want money, right? They what we call issue a bond, meaning they will ask you to invest in them and give them money. So a bond is issued by government or big institutions, and it's the way that they borrow money from you. Now, they, for instance, will ask you, let's say the bond costs 100 Rand. It normally is issued in 100 of rands, and then the price is as expressed as a number of rand per 100 units. And that's why what we call the R percentage. As we go along, you will see that later on. Normally, the nominal amount of a bond, or one, is the nominal value of 1 million Rand. Now, if we give the government 1 million Rand, then because we've done DSC 1630, we want to know what is the return on this money. You don't just give an investment or give somebody money without at least want some money back in return for the use of your money. So what the government does is, firstly, if you issue it, let's just work with 100 Rand. If you give them 100 Rand, then at the end of a long time period, right, that bond will mature, what we would call mature or maturity date. So after quite a long while, that 100 Rand will then, or the bond will mature, and they will give you your 100 Rand back. Okay, fantastic. You've given them 100 and they give you 100 Rand back. But what do we know? Don't we get something for our money? Yes. In this case, although they're giving you 100, they give you what we call just interest, but they just call it a coupon. Every 6 months, they will pay into your account an amount of interest, and we call that a coupon. And big C for C, and because this coupon is half yearly, we divide it by 2. So the coupon rate is normally per year, but we divide it by 2 because it's half yearly. So here we issue what we say we issue, that specific bond, a very long time period, let's say 30 years, it will mature, you will get your 100 Rand back, but in the meantime, you will get some interest, what they call then a coupon. Now, this term of the bond, as I specified just now, is very long. Now, sometimes you don't want to wait 30 years or 40 years before you get your 100 Rand back, although you do get your interest, or coupons as they call it, every 6 months. You might want to sell that, or you want to get your money back. So that's what we call, you sell your bond to somebody else, and that date that you're selling it and the trade took place and the money is transferred, we call then the settlement date. Right, so up to now, we had an issue date, we had a maturity date, we've got coupons, and then we've got the settlement date. Now, something else that's also applicable with the bonds is what we call the yield to maturity. The yield to maturity is the interest rate that's saying, if you've kept the bond from here till the end, what would have been your yield on that whole investment or on that bond? And that we call the yield to maturity. Why? Right? And because it's half yearly, again, we would divide it by 2. So the yearly rate is normally a yearly rate given to you, and then you divide it by 2. And that we call then the yield to maturity. So if you've kept it all along, right, it would have been whatever, let's say 10%. But that is different from your coupon. Your coupon stays the same. The yield to maturity is what the bonds on the stock exchange trade on. They trade on an interest rate we would call the yield to maturity. Right. Basic information. The bonds, what would we normally ID it as? You will definitely see there's a bond somewhere there, the word bond. And the calculator, we will use the financial and the normal mode as such. Right, on the board, presentation board, there we've got the issue date, the maturity date, we've got 100 Rand that's given back to us. Every 6 months we get a coupon. The half-yearly coupon they call D, or you can just use the C over 2 if you want to. And the same with the yield to maturity is Y, but because it's every 6 months, it's Y divided by 2, and sometimes they call that Z. Now, we want to sell our bond, let's say, on that little cross over there, that settlement date, right? Now, if I want to sell it, I must put a price to it. Now, what am I going to use? Am I going to use just the 100 Rand? If I use 100 Rand, then what's going to happen when I sell it here? What am I actually losing? What gives value to this bond? Firstly, it's these inflows of my coupons, plus the 100 Rand that I'm going to get back at the end of the day. So what gives value to a bond in general is that coupon that's being paid into my account, plus at the end, the 100 Rand that I've invested, they're going to pay me back. So the value of a bond is determined by this stream of coupons as well as the 100 Rand there. So if I want to determine the price of the bond at a certain stage, then the price will then be the value of all these things that I'm going to lose out by selling it. So let's say I'm doing it here. So what will I be losing? I will be losing those ones there because the new guy that's got the bond now in his name will receive those coupons, plus he will also receive the 100 Rand there. So if I want to know what the price should be, it should include this stream of my coupons as well as the 100 Rand. Now again, can I just add them together? No, because they're in different time periods. So what I do then when determining the price of a bond, I will move them all to the same date, which is exactly on the last step to the date which is the settlement date. But if you look at this here, I divide them in 2 separate stages. I would say I want the present value of my stream of my coupons plus the present value of my 100 Rand. That will actually give me the price, right? So I split it in 2. I work with, firstly, with full periods. If you look at the timeline, you can see there's full half years, but here we've got what we call odd periods. So to get to a price here, we need to work with full periods as well as fractional or parts of or odd periods, as you named it, to get to a price of here. Right. So what we'll do, we get a present value of then my coupons, a present value of my 100 Rand, add them together, and that will then give us an indication of our price that we will ask for our bond. So there you can see on the screen, we've got the C over 2 up to the maturity date, and they're all half yearly. But your settlement date, look at that number 2 there. They're the odd periods, as you can see here. So because of this full periods here, we work with the full periods as well as the odd periods. So the first thing we'll do is we'll calculate the present value of the things we lose out on when we sell this, which is the coupons and the 100 Rand here. We will first use the present value, but we will calculate it on what we call the next coupon date after settlement. So what is very important with bonds is you need to not only know what is your settlement date, but your coupon date before the settlement, as well as the coupon date after the settlement. Why? Because we're first going to work with full half-year periods to get the value of our price here at number 1, which is at the next coupon date, and then we will move it back using odd period calculation to the settlement date to get to an answer. Right, so we first determine the value on the first coupon date after settlement, as I showed you. So we will first work out our present value there, right? And how do we calculate that, the present value over here? Here we've got what? A stream of that. Equal time periods, equal amount of money. What do we call that again? Can you remember? Annuity. So how do I get a present value of annuity? Can you remember that? Present value of annuity is RANI. Can you remember? Right, but R in this case is this the half yearly coupon. How do I get the present value of my 100 Rand? I move it back in time to here. How do I move money back in time? Remember, we had it in the previous examples, in our previous chapters as well. If I move something back in time, I want a present value. It's the future value divided by our interest component, right? Or we multiply it by the negative. That's another way. So what we do is we determine the value here, which is the next coupon date after settlement. And we get that. We get the present value of annuity plus then the present value of 100 Rand that you will be receiving. We move back in time. Right, there's an indication again giving you a diagram how you've done it. Firstly, those C over 2, the red, we move back to here, which is the next coupon value. And the 100 Rand, we also, the green value, move back to here. And that gives us our present value at the next coupon date. So if we put these two values or two formulas together, we can say that if we've got our C over 2, right? These are all the C over 2s, our coupon, and the 100 Rand here. And let's say our settlement date is here somewhere. We will firstly take this stream and bring it back to now, and 100 Rand we'll bring back to our next coupon date here. So our present value at our next coupon date is then our C over 2, right, A-N-I, right, I'll talk about N and I just now, plus the 100 Rand that we divide by or we multiply by the interest component, minus N. Now what is N and what is I? N is the number of half years from this coupon, the next coupon, up to maturity. That is your N. The number of half years. What is I? I is your yield to maturity. Yield to maturity, which we also indicate with Y. But remember, we divide by 2. Why? Because we're working with half-yearly coupon rates. Right? So our interest rate we divide by 2. Right, so this will give you the present value at the next coupon date, on the next coupon date. Remember, here's our settlement here. Right, so this is the first step we normally do with calculating. We calculate our present value at our next interest rate or coupon rate date. Now, why do we do this? Because we can work with full periods. We know for annuity, this is the formula, and we know with compound interest, if you move something back in time, you can just move it back by dividing by the interest component or multiply by the negative component, negative exponent. Okay, so let's get then the value here. But let's just look at this formula. Remember with the present value of annuity, right? This formula, what formula was this for an ordinary annuity or an annuity due? This was for an ordinary annuity, meaning the payments were made at the end of each period, right? So if we go back to our formula, on this date that we're calculating this price, there's also a C over 2, right? So what happens with that C over 2, that coupon? Mustn't that be added to our price as well? Because it's not included in this formula, because we've just got a normal annuity formula there, ordinary annuity. We don't have annuity due. So that C over 2 there, this one here, is not included. The C over 2 here is not included in our formula here. Now, what do we do with that one? And that depends on what we call cum interest or X interest. Meaning, if we look, let's go back and draw a timeline, a nice looking timeline again. Let's say there is our settlement. Here is the coupon for the settlement after, and that is our maturity. So there goes a C over 2. C over 2, that's our settlement. Right. So we're worried about this. That's not included in our formula there on the board. Right. Now, they say, if this, from this date, settlement date, till the next coupon date, is greater than 10 days or equal to 10 days, that then there's enough time to take this bond and put it into the new guy's name, then he will be receiving this next coupon, right? And then we call it cum interest, meaning to our formula we had here, right, when we calculated that value, we still need to add a coupon to it. Why? Because this guy that's now buying the bond is going to get this because there's more than 10 days, right? And that we call cum interest. Now this value, the value between the settlement date and our next coupon, we call the value R. So if our R value is greater than 10 days, we say it is a cum interest rate, and we add another interest. If it's not, if R is smaller than 10 days, we don't add anything, and we say it's an X interest case, we don't add anything. Right. Why? Because you that's selling it, is still going to get that C over 2. So you can't add it there if it's an X interest case, right? So it's R smaller than 10, you don't add a coupon. So if we want the final price then on this date here, right, what do we need to do? The value of, depending if our R value, we must either add another coupon, half-yearly coupon, or we just leave it as it is. And that depends on our value R. So our second step always in the calculation is we would determine the R value and make sure, do we need to add that coupon or not? Why do we add a coupon? Because it's not included in our price formula, and depending on the number of days between the settlement where you buy it and pay for it and the next coupon date, if it's bigger than 10 days, the new guy will receive the coupon. If not, you will still be receiving it, and you can't add it to the price because then you will overcharge that specific person. So the second step is then to get the price on for the full periods on the next coupon date is we add a coupon or not. Go back to our board. Sorry about that. Okay, so that's C over 2. Why? That's 2 at the next coupon date. That is not included in our formula, so we either have to add it or not, depending if the next guy is getting it or you. And we're looking at that value there, what we call our R value. So the R value is the number of days between the settlement date and our next coupon date. And then something else that we also need later on is the H value. And the H value is the value between the coupon before the settlement and the coupon after. So the coupon date before and the coupon date after, the number of days between them are called the H value. Okay, so now, where are we now? We've still got the value up to now here. But where do we want it? We want it here. So what do we still have to do? Draw it again. Okay, we've got our coupons. Guys, I'm drawing 1 or 2 coupons. I'm not going to draw all of them. And let's say there is our settlement date. So what we've done up to now, we've calculated a value there, right? That was our first step by using our formula. P equals R ANI, but the R is just our coupons plus the 100 Rand that's moved back. Right, 1 plus I over N, and here the Y is actually our Y over 2. Right. So firstly we calculate the value there. Then nextly we decided, okay, is this C over 2 is included or not, depending on the number of days between our settlement and our next coupon date, right? So it might be that we've added another coupon, the second step, do I add a coupon, yes or no? And that then gives us our price over here. Right, so we've got the price here now, but where do we actually need it? Here, where that transaction takes place. And there's some time there between these two dates, so we need to move this value here still back in time to the settlement date so that we can calculate this price, the exact price on that settlement date. Now, if you look at this, this isn't full half year, this R value, right? So we're busy working here with odd periods. Now, if you go back to the previous sections we had, What do we do with odd periods? We can do two things. We can use simple interest. Can you remember? We've used simple interest for odd period and compound interest for full period. Or there was one that was called fractional compounding, meaning we use normal compound interest, but this time period we express as a number or a fraction of a year. So what we do is this price that we've got here, we still move back in time. So we divide by the interest component, right? But our time period here on top, the T, is, because we divide by, it's R over H. If you didn't use the divide by here, it would have been P times 1 plus Y over 2 minus R over H, okay? What is R and what is H? I is this time period. R is the number of days between settlement and the next compound date. And H is the half year which this settlement period falls into. So it's the coupon date before the settlement and coupon date after. So you would take those two dates, and that will give you R, which give you H. And if you move that back to here, the settlement date, we then what we call calculate the all-in price of the stock. Meaning, all in, it's got the C divided by 2, which is almost the interest bit, right? And your capital amount that you invested, your 100 Rand that you're bringing back. So that's why we call it the present value. It's all included in the price. By moving that back, then gives you the price that you would ask for that stock on the settlement date. And we call that our all-in price. There's the formula on the board for you there. Remember, Z is Y over 2. It's just your yield to maturity. Your F is H over R. Here is the formula written out. Right, so if we look at a diagram, what was I busy doing? I was busy moving that value that I've calculated at the next coupon date. I moved it back using odd periods to get my settlement date price. Right, now as I said, this all-in price, meaning it includes the interest plus the capital amount. What if I just want the interest as such? That we call then the accrued interest, right? Now, depending if you used a cum interest case or an X interest case, the formula looks a little bit different. With accrued interest in the cum case, meaning that extra coupon is added, it's H minus R divided by 365 times C. Now, guys, very, very important is this C here. This C is the full yearly coupon. Can you see it's not C divided by 2? It's just C. So it's your yearly coupon, not half-yearly coupon. Okay, in the case of the X interest, the H falls away and easy to remember, times C again, the yearly rate, not the half-yearly rate. So that's easy enough. If you've got, in the previous steps, you've got the R, you've got the H because you've used them here, you can just substitute them into your formula to get your accrued interest. Now, this will give you your interest, but what if you just want the principal value? And that we then call our clean price. If we subtract, if we've got the all-in price, our all-in price minus our accrued interest, that gives us what we call the clean price. Right. So that gives us the clean price. It's just the all-in price that we calculated previously minus the accrued interest. Now, before we carry on and do an example, I just want to go back to, remember we had here, where do we have our formula that we started off with? This N value. How do I calculate N? And what did we say was N? N was the number of days, or not days, half years, that is from the next coupon date up till the end of time. What? So let's say, let's use a black one again. Let's say our maturity date is in 2020. Here's our settlement date. Let's say it is in 2011, somewhere in 2011. And this date here, our coupon will be then, let's say our coupons is in January and July. So let's say this is January, right? So our coupons will be every year in January and July. How do I know that? How do I know when my coupon dates? First thing is, your first coupon date is always the month that the maturity date is in, right? So if this date is January, every year January, you will get a coupon. So that's one. So let's say this date is the 4th of January, right? 4th of January, every year you will get a coupon. But now when is the other one? You can then just take this January and you add 6 months. Or if you want to, subtract 6 months. For me, it's easier, just add. January, February, March, April, May, June, July. So what will be my other coupon? Will be the 4th of July. Every year. So the 4th of January and the 4th of July, the same as the maturity date and month every year, plus 6 months, the 4th of July, you will receive then your coupons. Right. So if we say this is 4th of January, let's say this settlement date is the 4th of 14th of, let's make it April, okay? Then, this is our settlement date, which our two dates is January and July. So, on the one side, we'll have January, 4th of January, 2011. And afterwards, July falls after that, so it will be the 4th of July, 2011. Then the next year we'll have your coupons the 4th of January 2012 and then the 4th of July 2012 and so forth. Now if I want to calculate N, I'll just quickly just wipe out this one here. Right. Now if I want to calculate N, N is the number of half years since the next coupon. Remember, this is our settlement, so that's the next coupon. From the next coupon up till the end. So you would count 1, 2, 3, 4, 5, 6, 7, 8, and so forth. Remember, you count the period, not the dates as such. That is your N value. Now, if this is a very long period from 2011 to 2020, it takes quite a long while to calculate that specific N value with your hands if you want to. So what we've done, we've given you some hints how to calculate it. And that's the following. If this month, the month of your next coupon date, is the same as your maturity date. right? Then in that instance, all that you have to do, because it's January, you would have subtracted the 2020 from the 2011, because there's this full years, it's the same years. Subtract the amount, get to the years, and then multiply by 2 to get your values. We'll have an example just now. In this case, the July and the January is not the same. So what I do is I do a trick. I say, let's ignore this 4th of July, and I imagine that the 4th of January 2012 is actually my next coupon date. So I ignore this bit here for starters, which is 1 half-year period. Now, January and January is the same. So I know each year there will be, up to maturity, there will be 2 coupon dates. So what I do is I take the years and I just subtract it from each other, which gives me 8 years, right? But I want half years. So half years, or your n value, is then 8 times 2, which gives you 16. So its n value is 16, 16 half years from the next coupon date to the last. But what happened? We'd ignore this one so that we could have the same date that we can just subtract. So now, to have the exact amount here, we need to add one more, which gives us 17. Right, so your n value in this case is 17. So if they're not the same, to recap, you ignore that, go to the next one, work out the number of years by subtracting them, and just add that one at the end of the day. If they were correct, let's say this one here wasn't here, and our next coupon date was this one here, you would have just subtracted the 2, and it would have been 8 times 2, which is 16. Right. So the difficult one is to calculate n, is if the months are not the same. What's the hint? What's the trick you do? Ignore that specific one, go to the next one, and then work out your years and then your half years. We look at an example just now, guys. Right. Now, if we do get an example or if we need to do an exercise on these ones, I always say I've got a cake recipe. There's the steps to follow. A certain way that I would first draw a timeline, putting in the maturity date and my settlement date. Then I determine my coupon dates. Remember, this is maturity date plus 6. Then I draw the coupon dates, both sides of my settlement. I get my H, my R, my N. And now only do I start with my calculations. Calculating my p-value, then determine if I add an extra coupon. Then I've got my all-in price by moving that value back in time. I determine my accrued interest, and I determine my clean price. Now let's look at an example as we go along, and we're going to follow that steps. Question 1, consider bond XYZ. The coupon is 14.7% per year. The yield to maturity is 13.5%. We work on a nominal value of 1 million rand, right? So we're going to use our percentage rate, meaning 5 decimals, the answer that we're giving, what we'll get to that just now. So it's 14.7% per year. Our yield to maturity, 13.5. The settlement date, the maturity, and then it asks us the all-in price, the accrued interest, and the clean price. So if we draw our line, regards, I want to get black. We've issued it somewhere along the line, and here's our maturity, the 1st of January 2028. Right? We've got that. We know in between there's coupons. We'll do that just now. Right, that's our first. Our settlement date is 18 April 2013. So just there, round about there, and we say it's 18 April 2013. We need to determine the next and the previous coupon dates, but that we can get from our maturity date. Our maturity date is January, so we know our first coupon is also January each year. The second one is just 6 months after January or before January. It's the same one if you want to work it out. January, February, March, April, May, June, July. So our other coupon is July. So now we go back to our settlement is the 18th of April. Now there's a January and July. So in our case, the January here will be one coupon. And because it's still falling in this year, it's 2013. The year off, or the one afterwards, is 1st of July, 2013. Right. Next one here will be the 1st of January, 2014, and 1st of July, 2014, and then carry on. Happy with that? Right. Now, on there, so we've calculated our values. We've got our maturity date. We've got our coupon dates. Now we're going back to the coupon. The coupon is 14,7 per year. So it's 14,7 divided by 2. Sorry, 14,7 divided by 2, and so forth. Our yield to maturity, or our Y value, is 13,5 per year, but if we wanted Y divided by 2, because it's half yearly, it is then 13,5 divided by 2. Right, are you all happy with that? We've got our settlement date, we've got our next coupon, our previous coupon, we've got our coupon rates or coupon dates here, we've got our Y, and we've got our C over 2 values, right? And we've got our Y over 2, or they also call it our Z values, right? All that we still need is R, H, and N. What is R? R is the value between the settlement date and the 1st of July in 2013. And what is my H value? Is the half year which my settlement falls in. Guys, it's not this half year. It's not that half year. It's the half year what the settlement falls in. So it's the 1st of January till the 1st of July 2013. Now, how do I calculate those values of R and H? Can you remember the day table we had previously? You would look up 1st of July, the value, and the 18th of April, and the same year, January and July, subtract them from each other to actually calculate your R value. So if you go back, just get my date table values here quickly. The 1st of July, the date value is 182. Our 18th of April value is 108. And the 1st of January is 1, right? So if I want R is between these two dates. It will be 182 minus my 108, which gives me the value of 74. What is H? H is between 182 and this 1. So 182 minus 1, which gives us 181. Okay, what's the last thing we need to calculate is our N value. Now, our N value is from where to where? It's the number of half years from here till the end. Okay, what's our trick? Our trick is make sure the months are the same. Here's July, here's January. Are they the same? No. So what do? My trick is I ignore this one and move to the next one. Now my January and January is the same. So to calculate N, we work firstly with the years. So I would say 2028 minus 2014 gives me 14 years. But I want N, which is half years. So it's 14 times 2, right, which gives me 28. But remember, I've ignored that one, so I need to add one, which is give me 29. So now I've got all the values I need by just drawing it on my timeline. Could you see what I've done? I've drawn my timeline and working out all my different values. I've got my R value, I've got my H value, I've got my N value, I've got my interest rate. Right. And now I've got my coupon. And now I can go back to my formula and start by firstly, just go back to this one. Remember our steps? Firstly, I'm going to calculate the price here because I want the full, working with the full period. After that, I'm going to add a coupon, yes or no, and that depends on my R value. And then lastly, I'm going to get the value here, which is at my settlement date by moving it back. So if we go back, so I'm going to get the price on the 1st of July, this one, make sure, 2013. Right. So that is it. That is, firstly, our coupon rate, ANI. Coupon is 14,7 divided by 2. N, remember N we've calculated as 29. I is your date, your yield to maturity is 0,135 divided by 2. Okay, plus the 100 Rand that's got to move back, so we divide by all to the power 0,135 divided by 2 minus 29. Okay, that gives you the price of 107,55174 cent. Okay, why the percentage? As I said, we're working with 100 rands. So if you work this out and you take the nominal value of a million, you actually move it 5 to the back. Right. So this is 107,55174%. That is our value over here. Okay. Second step is now we must remember this coupon at that date is not included. And if we need to add it, this R value must be bigger than 10. Now R value is 74. So now R is greater than 10. Actually equals to 74. So we still need to add to our price another coupon, and our coupon is 14,7 divided by 2. And this gives you the final price on the next coupon date of 114,90174%. Right. Now again, where is this? This is the price here. Where do I need the price? Here. So I need to move it back in time. So if I want my all-in price, I need to take this 114 and I move it back in time. And minus R. R is 74. H is 181. Guys, remember the minus is before that, or in front of that. And that then gives you your total all-in price on that date, which is 111,87388%. Happy with that? That gives us then our all-in price. Why the percentage? As I said, we're working with hundreds, right? So if you take a nominal value of 1 million and you take away the 100, it gives you 4 zeros almost. So if you work this out to 1, 2, 3, 4, then you will get your rand value of 111,873.80 cents, right? But we're working with the percentage, it's just easier to work that way. So that's the all-in price. If I want the accrued interest, because it's cum interest, it's H minus R divided by 365 times C. Remember, C is your full coupon. 181 minus 74 over 365 times your coupon, and our coupon value was again 14,7. Right, and that will give us the value 4,30932%. That's your accrued interest, and lastly your clean price is just the two subtracted from each other, which gives you the 111 of your all-in price minus your accrued interest, and that gives us a clean price of 107,56456%. Then our clean price, it was just our all-in minus our accrued interest, and previously we worked out our all-in price. Very important. Remember to add your coupon because your R value was greater than 10. Looking at quickly on our PowerPoint, we draw those values. Then our maturity dates, we got 1st of January and the 1st of July. We then added them to our timeline. We calculate our R and H value. We calculate our N. Then we substitute it back into our P value. Then we move it back, added the coupon or not. We added, in this case, we've added it. Then we determined the all-in price. And from the all-in price, that's what we did. From the previous step 7 and 8, we've moved it back to the settlement date. We can calculate our accrued interest and then determine our clean price. Now, guys, this is quite a mouthful. I know some of you are not so happy with the bond concept. Go over the video again. We're going to do another example on another video, but for now, this concludes this video. Guys, go back and do as many of these examples as possible. You know where to find the extra ones. So see you next time. Goodbye.